and welcome to this video tutorial in which we will talk a bit about inclines, grades and helixes. Yeah! This is a topic which, well, most people will encounter when they design a model railroad. And yeah, you know, the pulling capabilities of the locomotive is typically very nice. I remember a kind of unofficial world record attempt. I saw it on a forum called Marklinofsweden.net, and this guy, he had one of the old Marklin BR44 steamers, and with the rubber tires, friction tires, and they had laid out a long straight section on some huge logistic floor space, so it was all level, and they hooked up, I think it was in excess of 100 passenger coaches behind this BR44, and believe it or not, but it did actually start to move the entire set of, I think it was 120 passenger coaches, something like that. So the pulling capability of locomotives is tremendous, but as you start to have an incline, the amount of coaches that your locomotive can pull quickly is reduced. And if you're not aware about, you know, how to plan your grades and how to get around things, you can quite easily end up with only being able to haul 2 or 3 passenger coaches up the grade you designed. And it's as simple as that on a grade, the locomotive is not just pulling the train, it's lifting it. So why go through all that pain and headache creating grades on your layout if you not really have to? I mean, you limit the possible train length, and also you create potential danger of derailment. But of course, there are reasons that you cannot come around. And if we start looking at the typical US style layout, where they typically use a line called linear line design. And this is basically that the line, the train, the tracks, they follow the walls around the room as long as the walls are, and when they end, that's where the tracks end. So basically the idea here is that they don't want the line to pass through the same scenery more than once, just like in real life. And it makes much sense from a operational standpoint to do it that way. But they still need grades, and that's because sometimes you want one track to pass over another track, you know. So that is one reason to create grades on a otherwise flat layout or level layout. Another reason for doing grades on a linear line type layout is that you designed it for multi-deck. So you basically have one landscape up here, and then you have another landscape down here. So that's a multi-deck layout, and then you have typically a big helix, which is a curved grade inside, hidden somewhere, which transports the train in between these two different landscape bands. But of course, there is also grades in real life. I mean, if you travel with the trains along the lines, the landscape is not all level, obviously, especially not in the Alps or wherever. The lines go up and down, and if you want to, you know, follow that pattern, building a model railroad, you know, I'm building something where I have a grade which limits the train length in real life, I might want to have that also on my layout. You know, to have that challenge that going over this hill should be a challenge also when running model railroad. So there are also quite a few reasons to do grades on a linear line design. In European style, we typically build folded line designs, so the train passes through the same landscape or passing through the same scenery more than once. And then of course it looks much nicer if there's a difference in height between the first passing up front and the second passing in the back. And if you, like me here, I have my first passing, actually this is my second passing because you have a passing down here you cannot see, but I have my second turn here, and then I have a third one up here. So, but they're all part of the same landscape. So this is a very classic folded line design. And of course, then you need a lot of grades to support this, to transport the trains in between the different levels of your layout. But before getting into the actual construction of grades, we need to sort out also, because if you go into forums to, I want to read about grades and how to construct inclines and declines and what to think about, you encounter that there are different ways of talking about the grades. And I don't know if it's right or wrong, but I found that many double O gaugers, typically UK based, or people who moved from UK to other parts of the world like Australia, talk about grades in 1 in 30 or 1 in 50. And that basically means that you say you have, talk about centimeters here, then we have 1 millimeter raise of the track in 30 millimeter of travel. Or if you talk about foot, well, 1 inch in 3 foot, whatever measurement you're using. But that is the relation and how they talk about grades. While in the continental Europe, with Germany in the middle there, they talk about percent. So a grade is a percentage, and they're often saying like 2.5% is a nice grade to have. It will not create too much problem for you. And this is really just a calculation of what the UK guys are talking about. So 1 in 30, that means 3.3% gradient. But then of course there's a third one. And that is degrees. So you talk about the angle of your incline or decline in a degree compared to the horizontal plane. So you can have 1.5 degrees or 2.5 or something like that. And this much comes from the laser level instruments that's available in the shops nowadays. They often have a preset for degrees. So they don't speak 1 in 30, they don't speak percentage necessarily. Some of them can be switched over to percentage, but many of them speak grades. And then there is a difference between this. I'm going to show a chart here on the screen. And well, you can see now that I've already started out here to do some recommendations about the gradients and how they're expressed in these different measures. So, in general terms, I will talk about a very good design, which is 1 in 70. And that equals to 1.4% increase or so gradient, and that corresponds to 0.6 degrees of angle. And usage for this grade, I would say, is large US themed model railroads or huge Euro style layouts. And I will come to the bits and pieces and how I've been thinking in a minute, but let's continue here. And then we have this good design, which is 1 in 50, that equals to 2% incline, and that equals to 0.9 degrees angle. Well, a small US themed layout in a living room or somewhere, good fit for that, or on a very large Euro style layout. And then we're coming into what most people needs to settle with, and that is 1 in 30, which equals to 3.3% grade, and that equals to 1.5 degrees of angle. Well, I would say this is valid for small, medium-sized Euro style layout with folded line design. And worst case, I have a lot of worst case on my layout, trust me on this one, and it still works pretty well, but it's not something I would like, to recommend as a starting point for any design, but, it does work also with 1 in 20 and a 5% incline, and that equals to 2.3 degrees. And very small Euro style layout, it works fine. So, and if you're looking to run really long trains like 15, 20 passenger coaches, or even up to 80 freight cars, then you should not be looking at more than 1 in 80. That's the steepest grade you can live with if you're going to pull that with one single locomotive. And also, as I mentioned earlier, it's a big difference between Euro layouts and US layouts. Not because of the landscape, it differs as well, but it has nothing to do with this, of course. No, the American rolling stock is typically without friction tires on the locomotives. So it's just metal wheels. And of course that type of design will have much less pulling force than the European, like Marklin, Rocco, Pico, Brava, ESU. They all have rubber friction tires. So that vastly increase the pulling power and the ability to pull long trains up along kind of steep grades. So this is what does the difference. It's actually the rolling stock, and the Americans typically have smaller flanges on the wheels, more prototypic than the Europeans have. So this is also a limitation when it comes to coping with tight curves and also arrangement with grades, which is more demanding. So that's why I've differentiated Euro from US, not for any other reason. Then I made this chart. It's just to give you an idea of how much you can haul up on different grades with your rolling stock. And of course this is very dependent on what type of rolling stock you have, how heavy it is. In this example, used rolling stock which follows the NEAM standard of 0.4 grams per millimeter length. So if you have heavier rolling stock, like something which is in white metal, or then this will not be valid. It will not be valid if you don't have rubber friction tires either. And it's valid for single head trains. So just one locomotive, typically with bogies, so 4 wheels. Then this is the result of tests I've done with it. This is just to give you an idea of the difference here, and also what your objectives are with your layout. What type of trains do you want to run on your layout, and how large is the layout? Maybe the layout is not so large, then you cannot anyway pull very long trains because it will not look all that good. And then steeper inclines is not a problem for you. As mentioned earlier, one very common reason to create grade is that you want one track to pass over another track, like that. So a crossing, but not in level. And there is a way you can save both space and also the amount of grade needed to achieve the passing during the length of your layout. you know, because a grade takes a lot of space. And that is to have a, I would say, the normal level, not on the bench work, you know, not on the baseboard or whatever you're building your layout on. No, you have the normal level, the 0 level, elevated on, I would say, 50 or 100 millimeter over the bench work. And this way you can easily both go down and of course you can go up as well. So when you want one track to pass under another one can go down and the other one goes up in equal measures, and thereby you shorten the required distance by half, which is a good thing. And also I have here on my layout this arrangement. Here the tracks are not passing in and under each other, but I've used it instead to avoid that one of the grades look ugly. You know, because if you have one track that needs to climb a certain amount in a certain length, then that grade will typically look very steep. And then you probably want to hide it. I couldn't do this here. This is the entrance to my locomotive station. So it needed to be visible. And then I let the main line, the parade route in front of it, go down. And then I didn't have to elevate the entrance to the locomotive station all that much, and the grade is within acceptable numbers. Even though I know that I will not pull any long passenger trains or anything up to the locomotive station, so I can anyway accept quite steep grades going up there, because mainly the traffic will be a locomotive just pulling itself, and then you can have significant grades as long as it doesn't look ugly. So once you get to the point that you start to build your layout and are constructing these grades, there are a few advices which are very valid, and that is to make sure to build the grades using a decent sub-road bed. And a good sub-road bed material is 12 millimeter plywood, you know, spruce plywood, and 12 millimeter is 1/2 inch. So 1/2 inch thick spruce plywood. And avoid having the joining between two of these sections, because they will be sections, because the plywood comes in sheets and you will have to cut it somewhere. Avoid having the plywood edge near the point where your grade starts. So you nail the plywood down level and then the grade starts, because otherwise the plywood will do like that. And you will have problem with that. You know, cars coming off, or derailment, or trains getting stuck. So don't do that. Screw the plywood down flat, level, and then start the grade a bit in. Another thing which is very important is to ease in and ease out of grades. And this is very easy with the flex tracks, because the flex tracks will bend. You can bend the flex tracks like this and get a kind of spiral entrance into, until you get to the grade you decided to have. And this ease in should be at least a one passenger coach, or preferably passenger coach plus one locomotive long, before you reach the grade you have planned for. And same on the other side. And if you know, it's not common, but if you also are going down after that, then you need a level piece, so you don't go directly from incline to decline, because that's a very bad design. It will cause you a problem. It's better to have at least two passenger coaches long with a level in between. if you, like many Europeans do, use sectional tracks or modular tracks, whatever you like to call them, like C-track from Marklin, for instance, then they will not bend. They're stiff as anything. So what you can do then to get a reasonable easement in and out of a grade is to use shorter track pieces. So instead of your standard, whatever it is, 188 millimeter, or even the longest one, I cannot recall the length, but it's 240 or something like that. Don't do that. Go down to instead a 90 millimeter section. So take 1, take 2, take 3, maybe at least 1, 2. So you get a reasonable easement, so every joint doesn't increase all that much. So because otherwise what happens is that the first incline will lift the front wheels of the locomotive, and if it's a buggy type locomotive, then this is most often no problem. But if it's a long stiff, like a BR41 for instance, you will get stuck, trust me. So take shorter sections to get a reasonable smooth transition into the grade. And a good design advice is to not have switches, turnouts, points in the grade. Have instead the turnouts assembled in the sections ahead of the grade a bit, so you don't have to have them in the grade. And same with, it's preferred to build grades with just straight sections or curved. We'll come to that in a moment, but to mix it is in general not a good idea. So to have a straight section first and then coming into curve is asking for problems. And I will explain to you why. Because the Euro couplings, they look like this. So they have a neem mechanism, which the function with it is that it should fall out in the curves. So it extends in the curves to allow for very tight curve radiuses. And then in the straight section, the train comes together and looks like a buffer to buffer, very tight and neat, very prototypic. So it's a good thing. I like it. It's very nice. But it has several drawbacks. And one of them is that when the train goes downhill in a decline, the entire train will push onto these neem mechanisms. So they will be pushed into center position. And if you have a long train pushing, the first coach or freight car, the force on the neem will be significant. So what happens if you enter a curve in that situation, the neem will not go out. So what happens is that the locomotive is heavier than the first car, so it will push the car off the track. And this is a very common problem if you arrange it like that. So in the decline, somewhere in the end, you have a curve, and well, that's not a good idea. If you can avoid it, avoid it. Otherwise, it's much better to have a consistent curve radius over the entire grade, because you don't encounter this problem in that case. And that brings us into helix design. Well, helix is basically just a curved track which takes your train from one level to another. So upwards in one direction and downwards in another direction. So that's a helix. And you can either fit it in the room next door, so you don't have to have it in the layout room, you have it next door if you have that space for it. Or you can have it hidden under the landscape. Now there will be a significant amount of floor space that gets lost when you hide the entire helix under landscape. So what you can do is that you can have just one of the curves visible and the rest hidden in the landscape, for instance. But before getting into the bits and pieces and how to construct it and what you can do and not do, we should look at curves. Because even pulling the train around a curve on a level surface creates extra friction and more power from the locomotive than just pulling it on a level straight section. And there's a guy, he's called John Allen. He made a calculation, or at least defined a thumb rule for how much this will add when designing a helix. So he came up with that you take the curve radius you've decided for your helix. So you take 32 and divide that curve radius in inch, and you get a adder in percent to the grade you've selected for the helix. Did you follow that? So let's put this knowledge to use and use the thumb rule here from John Allen for a very, I would say, common design for Euro layouts, and that is to use 420 millimeter inner radius, which equals to 16.5 inch approximately. And 420 millimeter curve radius makes a total of line one full turn of 2640 millimeter travel. And let's say we want to have the pantographs up on the electrical powered locomotives. It's nice to drive with the pantographs up. Since we have catenary over the entire other part of the layout, we want it to look pretty. So we go for 100 millimeter passing height in the helix. That's good, because then you can also have good access if anything derails or so. So why not? 100 millimeter is great. Then we have 12 millimeter of material as well. So the total height from one track to the next will be 112 millimeter. And that on one full turn equals to 4.2% of grade, which is already on the steep side, I would say. You can pull trains up there of reasonable lengths, but not all that much. But then we have to add also John Allen's thumb rule of whatever the adder could be. And for 420 millimeter or 16.5 inch, 32 divided by 16.5 equals to 1.9%. So this will give us a total of 6.1% grade on a helix with an inner radius of 420. And 6.1, that is way outside any recommendations for grades on the model railroad. I don't even have that on my one. So it would not be very nice. The trains will be very short, and many of the locomotives will hardly even be able to pull themselves up in that helix. So we skip the requirement of pantographs up. We go down to 80 millimeter passing height instead on this 420 millimeter or 16.5 inch curved helix. Then we instead end up at 5.3% grade, which is also way outside the recommendations for grades on the model railroad. And since most of the trains will pass through the helix, that is typically what happens, then 5.3 is not a good design. So that tells us that the 420 millimeter curve radius is a no-go at any time for a helix. The smallest or tightest radius you should look for if you have very, very limited space is 630 millimeters. And with 630 millimeters and 100 millimeter passing height, you will end up at a 3.3% grade, which is, you know, within range. It does the trick, and that's, you know, anything wider than that is of course much better. But you know, if you don't have the space, 630 millimeters. I would say the most common material to make the sub roadbed in the helix is plywood, because it's in the DIY store and it's really easy access and not so expensive either. So it's really nice. But the spruce plywood, the quality of the spruce plywood varies a lot, and especially the cheaper ones are not all that good. So they will be sagging over time. So when I built my helix, I selected a plywood made on hardwood, birch tree, because it's kind of common here in Sweden, and the plywood is, well, it was kind of twice the price compared to the spruce plywood, but the hardwood plywood will never sag. It will maintain its shape for like ever. So that's definitely an advice I can give you if you want to live with your model railroad for a long while. Make the helix from hardwood. We're going to visit a Swedish guy here, who's building a huge Southern Pacific layout along the themes of the Siskiyou line in the United States. And he's been spending a lot of effort, putting a lot of effort into both the helix design, but also grades, because this Siskiyou line is a very steep, it's in the mountains. So he wanted to simulate that also on his layout, you know, adding the difficulty to haul long trains up the grades in the prototype. So let's go to minus.
This is the helix which transports trains from one level in the multi-deck to another level, but also from the lowest level in the multi-deck down to the staging area, which is located below the layout. Magnus has also selected hardwood plywood. This one's also from birch, but a thicker quality. He used two 6mm sheets, which he glued and screwed together, making a total of 12mm, half inch. The vertical supports are made from M8 threaded rods, which are bolted with hex nuts on each level, like this. The threaded rods gives you a lot of opportunities to make fine adjustments to heights and get everything really perfect. The framework underneath the helix is very sturdy. You can actually stand on it and it will not budge. So, very nice construction. All the joints in the tracks are, of course, made with the rail joiners, but they're also soldered. The flex tracks has been formed to the correct curve radius by the use of a wooden template, which has been pre-cut and laid next to the track. This way you get a consistent curve all around. Then also mounted these type of cameras, so you have visibility, what's happening there in the next room, next door, with the trains going up and down. This train we're watching here is pulling 36 freight cars, or box cars, and it has 3 engines pulling it. And now another train which is on its way up, also pulling about 40 cars. So this helix here has a grade of 2.2%, and the inner radius track has a curve radius of 820 millimeter. And we're following this train now to the upper exit, which is on a level from floor just around 1 meter 85 centimeters. whilst another train is entering the helix at the same moment. So all in all, a very well working design with decent numbers of the grades.
All right, so I think Magnus' design and execution of the build, actual build, is very nice, and it's a good example of how you can use grade to create a realistic prototypic layout, and also combining it with this well-designed helix, which moves the trains from in the multi-deck layout. So very nice. It was a good thing to visit him and to show you how things can be and should be done. This way you don't have to cut back on train length and you know, all the headaches with derailments and things like that. Good design and well executed, that really gives fruit, of course. I hope you have useful information provided in this video about grades and helix design for your coming model railroad layout projects. And if you like the information provided here and want to support the channel, please get over to Patreon, set up a support account there from, you know, like $1-2 per month. Or make a one-off donation using the PayPal dialog found in the video description below. And if you're not yet a subscriber, subscribe, enable that little bell next to the subscription button, and you will get a notification once next video gets published. Until that happens, see ya.